We're starting Unit 3, which is about gathering data. So we're going to be looking at how we can appropriately collect data through surveys and experimentation. But we're going to start with Chapter 11, which is understanding randomness. Why be random? What is it about chance outcomes being random that makes random selection seem fair? There are two things. The first is that nobody can guess the outcome before it happens. So you don't know. So that seems to make it fair. The second is that when we want things to be fair, usually some underlying set of outcomes will be equally likely. However, there are many games where the outcomes are more likely than other outcomes, but we can deal with that later. For example, picking heads or tails. If you flip a fair coin, does the outcome match your choice? Did you know before flipping the coin that it would come up heads or that it would come up tails? You didn't. You guessed, and you may have been right or wrong, but either way you had a 50-50 chance of that happening. So randomness. On the next slide, I want you to look at the numbers quickly and pick one at random. Actually do this. Do not just skip this section. It's actually interesting. So, are you ready? On your mark, get set, go. So, what number did you pick? If you picked the number 3, 75% of people would have picked 3. If you picked 2 or 4, 20% of people picked 2 or 4. And if you picked number 1, you are of only 5% of people that would have picked the number 1. We'll talk about this in class tomorrow to see what everybody actually did, but it will break down that the majority of you would have picked 3, followed by 2 or 4, followed by the number 1. When I did it for the very first time, I picked the number 3. That goes to show that it's not actually easy to be random. Random numbers are difficult to get. Our brains do not work randomly, even if you are trying to pick random numbers. You will either start picking numbers in a pattern, or you will end up using your favorite number more often than other numbers. Computers are better than humans, but computers give us pseudo-random numbers. So a pseudo-random number is a number that is generated in a fixed sequence that will eventually repeat itself. So pseudo kind of means fake, so they're fake random numbers. They are almost always going to be good enough. They're virtually indistinguishable from truly random numbers because their pattern is so long. So if you are using your calculator or computer, it will be good enough, but it's still not perfectly random. There are ways to generate random numbers so that they are both equally likely and truly random. The practical randomness is where we imitate a real process so we can manipulate it and control it. In short, we can simulate reality. So a simulation. The sequence of events we want to investigate is called a trial. The basic building block of a simulation is called a component. Trials usually involve several components. After a trial, we record what happened, which is called our response variable. There are 7 steps to a simulation. The first step is to identify the component that is to be repeated. The second step is to explain how you will model the component's outcome. The third step is to explain how you will combine the components to model a trial. The fourth is to clearly state what the response variable is. Then you run several trials. Then you collect and summarize the results of all the trials. And finally, you state your conclusion. When we are doing a simulation, performing the simulation is only part of it. We have to actually explain everything. So you will be required to actually write a few sentences explaining what you're going to do it, then analyze it, and state your conclusion. Let's look at our first example. On January 1st of every year, many people watch the Rose Parade on TV. The week before the parade is very busy for float builders and decorators. Roses and other flowers are purchased to decorate the floats. Based on past experience, one decorator found that 10% of bundles of roses do not open in time. 20% end up having bugs, therefore they can't be used. 60% will turn out to be beautiful, and then the rest will end up blooming too early. We want to conduct a simulation to estimate how many roses the decorator will need to buy to have 15 good bundles. What we need to do here is we need to follow those 7 steps to a simulation. We need to identify our component. How are we going to model that component? What is the response variable? And then what will our conclusion be? So our component here is one bundle of roses. And then we have to determine whether it's good or bad. And then we need to figure out what a trial is. And in this case, a trial will end as soon as we have 15 good bundles. So we have to write that up. So we're going to describe how we would use a random number table to conduct this simulation. So the description for a random number table is slightly different than if we are using a random number generator. We're going to look at one digit at a time. So all of these percentages, we have 10, 20, 60, and then the rest is also 10%. So they're all nice, even percentages. So we need 10 digits. So that would be 0 through 9. So looking at one digit at a time, we're going to let 0 equal a rose that does not open. A 1 or a 2 is a rose with bugs. 3 means that it bloomed early, and then 4 through 9 are the beautiful roses. Those are the ones that we're looking for. So starting with the first digit in the row and moving across, we're going to look at digits 4 through 9, the beautiful roses, until we have 15. So I put until you have 15, which is indicating that my trial ends as soon as we have 15 good bundles. Then we're going to count the number of digits that the trial took to get to 15, and then we're going to repeat this for several trials and then average our results. So once we've described what a component is, how we're going to model that component using the numbers, what the trial is, and then what our response variable is, then we're going to actually run the trials. We're going to show 5 trials on the number table below. So the number table I have on here is going to be the same one that you should have on your paper. And then we'll end up stating our conclusion. I'm going to use depend on here, and it's not very good, so you're kind of going to have to deal with it. So I'm looking for digits that are 4 through 9 to be a good bundle. And then you really want to mark right on here. So I'm going to put a check mark if it's good, and I'll just leave it blank if it's not good. So 9 is good, 9 is good. 4, 4, 6, 4, 7, 6, 7. So all of those are indicating that we have good bundles. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that trial ends right there. So now that trial ends, I can see how many bundles that took. And it took, these are in groups of 5, so 5, 10, 15, 20, 25. So this took 25. Then I can pick up a trial here. A lot of times if they want 5 trials, they might give you 5 rows and you can just go to the next row, or you can just keep going. Either way works. So I'm just going to keep going. So I have 9, 9, 7. So again, I'm just marking the ones that are good. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So again, this ends a trial. And so again, I have 5, 10, 15, 20, 25. So my second trial took 25 bundles. And then we keep going. So I'm going to ask that you stop now and you do your next 3 trials. You should end up with 24 bundles, 21 bundles, and 20 bundles. Once you have all of your trials completed, we then will state our conclusion. So in this case, our conclusion is going to be, after the 5 trials resulted in buying 25, 25, 24, 21, and 20 bundles, the average of these is going to be 23. Therefore, the florist would need to buy an average of 23 bundles. Now, there is another way that we could go about doing this. We could look at this and say the maximum number is 25, so he should buy 25 bundles, because based on our trials, that will guarantee that he does this. Or you can take an average. Either way in this situation would be appropriate. You would just have to explain, if you went with 25, why you are going with 25. Again, it's that explanation and putting things into context that is going to be so important in this class. Looking at the second example, Billy is taking a 6-question multiple choice quiz, where each question has 5 options. He claims to have guessed on every question because he didn't study. It turns out that Billy got 4 out of 6 correct. Does this seem likely, or is something up? We want to describe and conduct a simulation to answer the question. In this case, they're not asking us to use a random number table. So I'm going to say that we can use our calculator, and I will show you how to use your calculator tomorrow, but it's really just using the random integer generator, which I think most of us have done, but I will go over it tomorrow in class with you. But the first thing that we have to do is we actually have to describe. So we need to identify what a component is. How are we modeling this component? We have to explain how you will combine the components that are going to be a trial. What is our response variable? And then do it and then state our conclusion. So in this case, one question is a component. There are 5 options. Because we're going to be using a calculator, we can be very specific. We're going to pick numbers 1 through 5 because there's 5 options. And then let one of those numbers be a correct response, and then the rest would be a wrong response. And that would be one component, and how we'll model that. A trial will end here after 6 questions because the quiz has 6 questions. So that's going to look like this. Using a random number generator, I will select 6 numbers from 1 to 5 to represent taking the quiz. I'll let 1 equal a correct answer, and then 2 through 5 will be an incorrect answer. I will record if there were at least 4 answers correct. Then I'll repeat this several times, and then find the percentage of times where we had at least 4 correct. I went ahead and did this already on my own calculator, and I did 12 trials, and these were all of the numbers I got. So I'm looking for how many times I ended up with 4 correct. And in this, like on this first trial, I only got 1 correct answer. In the second trial, I got no correct answers. I never really actually got more than 2 correct here. The percentage would be 0 out of 12 because I did 12 trials. 0 of them were anything that I wanted. So my conclusion would then be, after the 12 trials, there were no simulations where 4 out of 6 questions were answered correctly. Therefore, it seems like something is up. So you do need to answer the question that was asked. It asked us, does this seem likely or not? And no, this does not seem likely. So he either studied, or cheated, or had background information, or something. So those are the 2 different type of simulations. In one simulation, a trial doesn't end until you get your result. And then in another one, the trial has a specific length, in this case 6 questions. We will discuss these examples if you have any questions about them, but we will also do a few more examples in class tomorrow, just to make sure that we are comfortable with this. Other than that, that is it, so have a good night, and I'll see you guys tomorrow.